geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is match list 1 with list 2 kind of question. On the list 1, it is asking like this. Kinetic energy of planet, gravitational potential energy of sun planet system, total mechanical energy of planet, escape energy at the surface of planet, unit mass object. Under list 2, minus gmm by a, gmm by 2a, gm by r, minus gm by 2a, where a is the radius of the planet orbit, r is the radius of the planet, capital M is the mass of the sun, small m is the mass of the planet. Dear friends, remember here the kinetic energy of the planet is equivalent to gmm by 2a. Therefore, A2 correct. Next, gravitational potential energy of sun planet system is equal to minus gmm by a. B1 correct. Then total mechanical energy of the planet is minus gm by 2a. C4 correct. Escape energy at the surface of the planet unit mass object is gm by r. D3 is correct. A2, B1, C4, D3. A2, B1. Look at the options. Look at the option B. A2, B1, C4, D3. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at the problem asking like this. A 90 kg body placed at 2 r distance from the earth surface. From the earth surface, let the earth is at a radius of r and m be the mass of the earth. But body is placed at an elevated height. This height h equal to 2r, and mass of that body m, that m is given as 90 kilograms. Then you're asked to decide what is the gravitational pull on the body. As you know, gravitational pull gravitational pull on the body equal to mg only. Mg only. But g at an elevated height, g equal to gravity constant at the surface of the earth, that is given as 10 into 1 plus h by r whole power minus 2. This formula we have clearly discussed. Do you remember? Yes. Then it is equal to gs into 1 plus h is given as 2r, h is given to r by r whole power minus 2. Therefore, g equal to gs into 1 plus 2 whole power minus 3 is equal to gs is given 10 by 3 power, it is minus 2, 8 minute. It is minus 2, 3 power 2 equal to 10 by 9. Therefore, gravitational pull on the body equal to mg. M is given 90 kilograms, 90 into 10 by 9, 9, 10 times equivalent to 100 newtons. That is a gravitational pull on the body. Option A is absolutely correct. Understood clearly? Yes. Similarly, let's take the another important question. Try to read it clearly. It is given like this. Correct formula for height of a satellite from the earth surface. You know, this may be the earth, radius is r, mass of the earth is m. The satellite may be somewhere here with a mass m. That satellite is available or orbiting at a height of h. That height formula you are asked to decide. At that particular height, it is going to revolve like this. It is going to revolve at that particular height like this. Okay, then on the surface of the on earth surface, you know, gm by r square equal to mv square by r. But the satellite is available at an elevated height, right? Above the above the earth surface. The above relation can be written as g capital M small m by r plus h whole square equal to mv square by r plus h. Okay, here m can be cancelled, small m can be cancelled. Then it can be written as, listen carefully. From this I can write that v square equal to how it can be written, v square equal to 1 r plus h is cancelled, gm by r plus h, gm by r plus h, absolutely correct. Let us take another slide. Here v square equal to gm by r plus h. But as you know, the linear velocity v equal to omega into r on earth surface, above the earth surface it is omega into r plus h, it is above earth surface. So v equal to omega equal to 2 pi by g into r plus h. Okay, but we want v square na, v square equal to what, 4 pi square by g square into r plus h whole square. So in the place of v square, let me write that value, 4 pi square by g square, right? 2 pi by t, na, not g, 2 pi by t, 1 minute. This 2 pi by t, you should be very careful. 2 pi by t square, 2 pi by t square, 2 pi by t square into r plus h whole square, right, is equal to gm by r plus h. From this t square equal to, otherwise he is asking height na, 1 minute. Let me write it clearly. R plus h whole cube equal to r plus h whole cube equal to, okay, you know, g equal to gm by r square, from this gm equal to gr square. So here r plus h whole cube equal to g r square by gr square by r plus, okay, gr square into t square by 4 pi square. Listen carefully. You should be very careful while we are discussing in the limited space. From this, r plus h equal to g r square t square by 4 pi square. whole power 1 by 3. Then h equal to what? H equal to g r square t square by 4 pi square whole power 1 by 3 minus r. That is the height of satellite formula from the earth surface. Look at the options. G r square t square, it is g r square t square by 4 pi square, g r square t square by 4 pi square whole power 1 by 3 minus capital R. Look at the option B, t square r square g, t square r square g by 4 pi square minus r. Yes, option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A light planet is revolving around a massive star in a circular orbit of radius capital R with a period of revolution capital T. It is given T equal to time period, time period, and R equal to radius of circular orbit, okay, circular orbit. If the force of attraction between planet and star is proportional to r power minus 3 by 2, then choose the correct option. It is given that force of attraction between planet and star, let it be F, is proportional to r power minus 3 by 2. From this I can write that the force of attraction is proportional to 1 by r power 3 by 2. Okay. As you know, the force of attraction is G capital M small m by r square. But here it is, the force of attraction is proportional to r power minus 3 by 2. Right? It must be equal to, this force of attraction is, balancing the, or is providing the required centripetal force. That required centripetal force is Fc, that is equal to m r omega square. From this you can write that gmm by r power 3 by 2 is equal to mr omega square. Let us cancel the small m on both sides. From this you can write that omega square equal to gm by r power 3 by 2 into r. It is equal to gm by r power 5 by 2. Okay, 5 by 2. Because 3 by 2 plus 1 is equal to 5 by 2. But as you know, the time period P equal to 2 pi by omega. From this omega equal to angular velocity omega equal to 2 pi by t. Alright, from this I can conclude that omega square is proportional to 1 by square of the time period. Okay. Since omega square is proportional to square of the time period, and omega square from this g constant, capital M constant, is proportional to 1 by r power 5 by 2. Therefore, 1 by 1 by square of the time period is proportional to 1 by r power 5 by 2. From this I can conclude that the t square is proportional to r power 5 by 2. This is the relation between the time period, and radius of circular orbit. Look at the options. T square is proportional to r power 5 by 2. Option A is absolutely correct. Understood clearly? Yes.
Geobyte.